Here are 4 examples of the tactics for balancing equations. So you can never change subscripts, we can only change coefficients, which are the big number in front. We want to have an equal number of each type of atom on both sides of the yield sign. So we're just going to work our way from left to right, each reactant one at a time. We have 1 sodium on the left side of the arrow, 1 sodium on the right side. Currently that is balanced. Next is the chlorine. There are 2 chlorines on the left, but over here there's only 1 chlorine. So I want to multiply that 1 by a coefficient that will make it equal to this 2. And so I'm going to put a 2 coefficient in front. And that counts toward the chlorine and the sodium. So at the moment I have 1 times 2 is 2 chlorine, that is balanced. But I need to go back and fix my sodium because this 2 modified the sodium. I have 1 sodium on the left, 2 sodiums on the right, so to fix that I'll place a coefficient of 2 on the left. So this would be considered a basic balancing. The second example involves a common factor balancing. So we will start with our phosphorus. There are 2 on the left but only 1 on the right, so I'm going to put a coefficient of 2 here. Now I have 2 phosphorus, 2 phosphorus. There are 5 oxygens on the left, 2 oxygens on the right. So it would be easiest to use a common factor of 2 and 5, which is 10. So I want to have 10 oxygens on both sides of my equation. So over here, by putting a 2 coefficient, 2 times that 5 is going to equal the 10 oxygens that I need. And over here, a coefficient of 5 times 2 equals the 10 oxygens that I need on the right. But I need to go back and fix my phosphorus because it's been modified. So now we have 2 times 2 is 4 phosphorus, and instead of having a 2 coefficient here, we want to change it to be a coefficient of 4. Let's double check that everything is balanced. We have 2 times 2 is 4 phosphorus, 4 phosphorus. 2 times 5 is 10 oxygen, 5 times 2 is 10 oxygen. Everything is balanced. So the final balancing is 2 diphosphorus pentoxides, 4 phosphorus, and 5 oxygens. And so here's the final balanced equation rewritten. The third example, it'll involve the addition of some of the reactants or products. So on the left we have silicon, 1 silicon. On the right we have 1 silicon, so that's good, we'll leave it alone. Now we have 4 chlorines. On the right we only have 1 chlorine. So to fix that I want to put a coefficient of 4 because adding the 4 here is going to give me my 4 chlorines on the right to equal my 4 chlorines on the left. So just to verify, silicon 1 and 1, chlorine 4 and 4. That's good. Moving over to the hydrogen. We have 2 hydrogens on the left, but on the right, we have hydrogen in 2 different spots, here and here. So we're going to have to add these 2 hydrogens to get my total on the product side. There are 4 hydrogens plus 4 equals 8 hydrogens on the right. So to fix it over here, I need some number times 2 to equal 8. And that's going to be a coefficient of 4. So we have 4 times 2 is 8 hydrogens on the left. 4 plus 4 equals 8 hydrogens on the right. Now I have 4 times 1 is 4 oxygens on the left, and we already have 4 oxygens on the right. So just to verify everything is balanced, we have 1 silicon, 1 silicon, 4 chlorine, 4 chlorine, 4 times 2 is 8 hydrogen, 4 plus 4 is 8 hydrogen, and then 4 oxygens, 4 oxygens. Here's our final balanced equation rewritten. Final tactic involves balancing when you have polyatomic ions. So in this example, we have lead, and then in the parentheses, we have the polyatomic ion nitrate. Anytime you have a polyatomic ion, you want to balance it like a bundle. On the left side still, we have potassium and iodide. And on the right side, lead, iodide, and potassium. And then here's our nitrate again, and I'm going to treat it like one bundle. So I'm kind of circling it to treat it as a bundle. So now when I balance this equation, we have 1 lead on the left, 1 lead on the right. Good to go. Now, nitrates. This subscript of 2 is outside the parentheses and states that I have 2 sets of nitrate. So I have 2 nitrates on the left, and on the right, I do not have a subscript on the outside, so there's only 1 nitrate on the right-hand side. So I need to have 2 nitrates, so putting a coefficient of 2 here will give me 2 times 1 is 2 nitrates, which is equal to this, 2 nitrates. Lead is still good, 1 lead, 2 nitrates, 2 nitrates. Now we'll move over to potassium. 1 potassium on the left, and this 2 in front of potassium is going to mean I have 2 times 1 is 2 potassiums on the right. So on the left, I'm going to need a coefficient of 2, because now that will give me 2 potassiums, 2 potassiums. Finally, let's check iodide. This means I have 2 iodides, and this subscript here means I have 2 iodides on the right, and so that's also balanced. 1 lead, 2 nitrates, 2 nitrates, 2 potassium, 2 potassium, 2 iodides, 2 iodides. Here's the final balanced equation rewritten. You may have noticed that we had some phase notations, aqueous, aqueous, solid, and aqueous. Those are not involved in balancing. You can just ignore them.